Hey, welcome to another adventure in old code. Well, it's time to take a look at some more small programs, being as how I can't find any number that divides into 71 perfectly. So, I thought we'd start today in the arrays folder and finish off all the dumb array programs. So we're going to start out with something called line today. January 12th, 1999. Here we go. This is line. So I am moving this cursor with the arrow keys. I think I remember this. I think if I hit space, it saves that point, and then I can draw a line somewhere else, hit space again, and that line stays. So it is a program that draws lines. Very awesome. Actually, it is pretty cool. There will be a deficiency, I'm sure, when I go across a line, or if I draw a line over existing lines, it erases them. But all in all, a nice little experiment. So that was good. All right, let's get out of there and see what's going on here. So we got our LRUND, our arrow keys, and something called A. Show and some arrays. Because this is part of the array folder, we're going to use arrays. Okay. Oh man, someone's screaming outside. You are now famous. You're on YouTube. Okay. Okay, so this is setting each... Oh my goodness. Are they done? I'm going to have to tag the explicit... mark this video as an explicit language.
Oh my goodness, this is not ideal. We're done?
I think they're done. Okay. Okay, X and Y are... he's going to go get his bike. Okay, X and Y are two-element arrays. We're setting both values of X to 320 and both values of Y to 240. That's right in the middle of the screen. Okay, SPFAC is 1. Good to know. Okay, and now we're going to draw a line from the X, Y. Okay, this draws the little plus sign centered at the X1, Y1 coordinate. -5, +5 on either side of the pixel to make that plus sign. So that's 2 lines. All right, and then we are going to start doing stuff. So space equals 0. If space equals 0, then x2 equals x1. y2 equals y1. So I think this is a flag that says, have we hit space? Are we currently making a line, or are we just moving to a position on the screen? If we're just moving to a position on the screen, then we're going to keep both coordinates, both points are going to be the same. We're going to just set the second one to be equal to the first one, and we continue to draw this line. This draws the plus sign. Then we ask for input, and we store that into A, and then we erase the line, color 0, erase the plus. If it was CHR string 32, if it was space that we hit, then space equals space plus SPFAC, which is 1. Space factor. I see. So this in later programs, I used -1 as a flag, and then I could just negate it, and so it would flop back and forth between 1 and -1. This, I'm always adding SPFAC, but I'm negating SPFAC, so not as intelligent as other programs. But this is going to flip between 1 and 0, basically. If space is equal to 1, then I'm going to draw a line from the second point to the first point, and I'm going to erase it. Because why? Because I'm moving. So I'm erasing everything. Now I'm going to get to the part where I draw things. If I hit left, I'll subtract 2 from x. If I hit right, I'll add 2 to x. And similarly with the up and down. If I'm currently drawing a line, then draw the line from the second point to the first point, and I loop until I hit escape. So that's it. That is line. Very nice. And escape. All right. Moving right along. We're going to look at something called cards. Okay. Here we go. 1 of hearts, 2 of hearts, 3 of hearts, all the way up to 13 of hearts. Yeah, sorry, previous Joey. There's no such thing as a 13 of hearts. Does this always just print the hearts? Okay. So I was making 13 spades, clubs, hearts, and diamonds, all string arrays of 13 elements, random number generator. Clearly I was making a card game, but I didn't finish or something. So, okay, for 1 to 13, for each value of the card, we are going to say spades of num equals the string representation of num plus CHR string of 6. Okay, so yeah, so for each card, we're going to just say, hey, is this 1? Then we're going to say 1 plus, and then a symbol. So this is the symbol for spades, 3 is hearts, 5 is clubs, and 4 is diamonds. We can see that from the ASCII character codes, which we've looked at before. There we go, 4, 5, and 3, 4, 5, and 6, right there. Cool. Okay, now we're fixing up the special cards. Oh boy, yeah. So we're checking to make sure, is it 1? Oh, that's awesome. Okay. So we wanted to say, okay, look, if this is the 1 of spades, we really want it to be the ace of spades. So I did a check here. From 1, change it to an A. 11 changes it to a jack, and 12 a queen, and 13 a king. And we do the hearts and the clubs and the diamonds, and then we print all the hearts, just, I guess, for testing purposes. But this didn't work. Why didn't this work? Because when you take the string representation of a number, we automatically get a space added to the beginning. So, unfortunately, I would have had to do this. This would have done it. Because space 1 is not the same string as just 1. Now, Oh, yeah. Okay, no. I'm gonna open up cards again. That's not the whole reason. Let's just make sure that yeah. So we're looking at spades of num, which we've set to be the string representation plus CHR string of 6. So no wonder this isn't being picked up. This has to be case 1 plus CHR string of 6. And then we should pick it up. Let's do the hearts here. Let's do plus CHR string of 3. Okay. Do we have an ace of hearts? No, we don't. We still have the 1 of hearts. And that's because this needs to be a plus sign, an extra space at the beginning. Okay, very complicated. One thing I noticed right away I could have done is instead of look at spades of num, we could have just looked at num. Not really anything wrong with that. Let's we'll only do these hearts so we can see. So that would have given us ace through king properly. But no, I checked the complicated string representation of the card and I did it incorrectly. Anyway, that's a deck of cards. Awesome. Moving on. We have something called cards 2. Fantastic. So this is obviously another deck of cards, but probably done in a more intelligent way. Okay, we've got 52 string values in card and 52 integer values in show. Random number generator. So this will give us our cards. For each card value, we're going to say card of A equals A plus CHR string of 3, which is hearts. And then we're going to see again, we're going to look at card A, which has a heart added to the end of it. And then we only look at 11. So this again doesn't have it suffers from the same deficiency as the previous one. So we make all of our hearts, make all of our clubs, and that's it. We actually don't do anything. It doesn't even run. Awesome. Okay, a program that doesn't run, it doesn't have any output. Clearly I was in the middle of doing something. I suspect this ended up... Okay, that was weird. I ran out of space. Anyway, doesn't matter. Okay, so this program doesn't work. That's what we got. Awesome. Moving on. Let's look at something called full. Very small program. All right. Yes. So this is my attempt at filling the screen with a bunch of dots. It's a transition. In a lot of these shoot 'em up games, did Doom do this? I don't know. Maybe Wolfenstein 3D did this as well. It's a dissolve. The whole screen dissolves, and so you sort of... yeah, you watch the whole screen change pixel by pixel or little blocks. I wanted to do that, but I didn't quite get the trick into how to do it efficiently. So that's why it starts really fast. I'm probably just picking random coordinates. And if it's already been picked, well, that's why it seems to go slower and slower and slower, because it's doing a lot of pixels more than once. We have to wait until everything gets chosen at least once. And it's very... So I made this. I thought, oh, I'm just going to recreate these screen transitions. And yeah, I realized there was something very, very inefficient about mine. So anyway, this is how I did it. A 2-element array row. That's kind of interesting. 8120. And then I have 480 columns. Random number generator. This is screen 13 this time. So for 1 to 80 by 120. Okay. Loop until... Okay, so that box is an 80 by 120 box. And there are just... I'm making a single value for each one of them. I set them all... They all start at 0. So I pick 2 random numbers between, somewhere in the box. And I loop until I haven't picked it yet. Oh, I see. So I'm not actually redrawing. I'm just randomly pick one. Have I picked it yet? If I haven't, then I'm going to set that to 1 and draw that pixel and then go back up here. And so what's happening is it slows down near the end. It's because it cannot find, it keeps choosing random numbers, but it's always 1 because I've already done set it. And so it just keeps going and going and going. So the proper thing to do is put all the values into a queue or something and just start picking them off randomly. Or put them all into a bucket and randomly draw things out so that you're guaranteed that the position that you choose hasn't been done yet, and then it won't slow down. But okay, that's fine. We're going to go to something called prime P. Awesome. What is this? Prime numbers. Beautiful. These are prime numbers. The best numbers in the world. You can tell it's getting slower and slower and slower, but it's still chugging out prime numbers. We'll wait until it gets to 1003. Oh, 1003 is not a prime number. Okay. Okay, anyway, that's great. There's no way to exit this program except a hard break. I've got a graph in there too. What? Hmm. 1 to 5,000. Let's just do 500. I want to see this awesome graph. Okay, that was weird. Okay, what's this all about? I don't even know. P P P P P P P P P P P P P P P P P P. All 1,000 element arrays. Clearing the screen, num is 0. This was 5,000. Okay. F is 0 for x equals 1 to a. A is what? The number we're checking. Okay. So a is the number we're looking at to see if it's prime or not. We're going to go from 1 to a and just check all the numbers from 1 to a. Does any number go into it? We just figure that out by a divided by x, which gives us a decimal. Is that equal to the integer of a divided by x? And if that's the case, then it's got a factor. And so f equals f plus 1. So each number will have two factors. So if f equals 2 exactly, then it's a prime number. It divides 1 and itself, then t, okay, that equals t plus 1. I'm going to store that into prime number equals a, print a. So I'm figuring out, is the number prime, then stick it into the array p. All right. Okay, that's fine. We can do that. Just 1 second, one more time. Okay, this is going to be the most cobbled together episode I've ever done. So, if a number has two factors only, then it's prime, and I dump it in this p array, and I print it out on the screen. Semicolon stays on the same line. That's why we're getting all the prime numbers on the same line. Go to the next one. So we're doing it 5,000 times, okay? And then we're going to clear the screen. And then we go from 1 to t. Now this, okay. Now we're only going to look at the prime numbers. So we're 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Those are the prime numbers. This is going to do that same calculation using t. So what this means is we're going to look at the second prime number, the third prime number, the fifth prime number, the seventh prime number, the 11th prime number. And we're going to store these into PP. PPTP. Because I needed another variable. I used t already, so I used TP this time. Oh, lovely. And then we print out that number. I called these second degree primes. My own invention. You have the prime numbers, and then if you take every prime number, you get the second degree prime numbers. And then we're going to go from 1 to TP, and we're going to do the same thing. We're going to find the third degree prime numbers. So the second degree prime, the third second degree prime, and you keep doing that. And then we're going to do it again to find the fourth degree primes. Oh my word. And then the fifth degree primes. And at this point, I don't know what I was doing. So that is why, if we go back here to 500, we'll find all the prime numbers from 1 to 500. That's great. And then we're going to find the second degree prime numbers, which are all of these. Those are the third degree prime numbers. And if we take the, the second, third, and fifth one of those, we'll get that. No, we don't. That's totally wrong. There's something screwed up with this program. But you know what? I don't even care. That is, I was trying to find second and third and higher order degree prime numbers, and that's how I did it. So, okay. Okay, that's it. I'm gonna call that quits. This has been a very difficult episode to get through. We've had people yelling. We've had car alarms going off. I had my phone filling up with videos, and I've had to stop it numerous times. So we're gonna give this a wrap. What do you think of my background? That's a new thing. We'll see how this works. All right. Thanks for joining me in this adventure in old code. Have a nice day, and we will see you next time.